fans, and welcome to another episode of the engineering channel fronted by a 5-year-old pillock. In today's episode, all the way from Newcastle via France, is that the right way around? No, France via Newcastle. We have these, which are Time ATAC pedals. Now these are a favourite of fixie riders. They all seem to use these, I'm not quite sure why. Anyway, the chap who sent me these, he has got like a heel-in pedalling style. So what he wanted was, he wanted the axle extended. So that is the new axle, that is the old axle. He couldn't quite muster pedal extenders because they would extend too much, like 14mm. And the usual trick of adding a couple of washers behind the pedals wasn't enough. So in this episode, I'm going to talk you through a teardown of this, which I'll tell you now is very well engineered, and this. So this is the Time ATAC ATAC pedal that the chap sent me. It is of, I suppose, late 90s, early noughties, probably even earlier than that, vintage. It could even be late 80s, I'm not quite sure. This apparently is one of the cheaper types that Time do, but nonetheless it is extremely well engineered. So it's a moulded plastic body. It's double-sided, so you can put your feet in that side or flip it over and it goes in. The spring retention is it's two single spring, a double spring. So the leaves are there, and there is one spring, and there is the other spring. The axle is through here, so we've got a 9/16 threads per inch thread to locate onto the crank, and then a preload system that is in here, and at this end there's a needle roller bearing. So the aim of this task was to get from there to here. What I'm going to do now is I'll weigh this just to show you what it weighs, and then we're going to disassemble it. For weight, we have 206 grams, which probably by modern standards is a bit on the heavy side. Just want to highlight a defect on here. When these two spring retainers have been put in, like a pin goes through and it gets rounded over by a tool that comes and smashes on the end of there. Same thing on the end of there. Now, when whoever has made this, the tool has missed slightly, and you can see a perfectly round indentation which matches the diameter of that. So they missed it by 3/4 of a hole. That in turn has caused that crack there. Now when I first saw it, I thought, oh, flipping it, the thing's cracked. But obviously it's stood the test of time, which is the best kind of test that you can have. So the pedal is basically over-engineered, but nonetheless the manufacturing is not perfect. Right, so to tear this down we need to remove this circlet, which is a bit of a fiddly job. So really you should clamp this up in a vise, but won't be able to see it otherwise. Oh, balls. I might just fast forward this to show you after I've removed it. And there we go, so that circlip's removed. Once that's removed we can pull the axle out. Which is a bit tight. Well. So this is it disassembled. Now what you can't see, because it doesn't show up very well, is there's a bearing in there. So there's a needle roller bearing that's probably sitting about here inside the pedal. So that sits on here. Now this surface has been hardened. It's quite obviously been hardened. So that takes only radial load. We've got an increase in cross-sectional size, and then we've got a circlip landing here, which I've partially removed. The 6901 bearing here, and then a sort of seal assembly, a shoulder, and then the threaded component, and then finally into here is I think that's a 6mm hex. Whoever's designed this has really gone to town with it. They've really thought about it very well. It may not be an expensive pedal, but it's been very well engineered. So the shaft is hardened here, it's been plated here, so it's not stainless steel or anything like that. They put an undercut in here, which is like a machining tolerance or a machining feature. There's another one there, and they've also put that circlip in there just to be sure to hold that bearing in. And there's another undercut there so that you've got full thread engagement if required. What I'm going to do now is I'm going to take this circlip off and then remove this bearing so that we can see what happens behind here. That's off. This bearing is an interference fit onto this shaft, so the inner part of this bearing is a smaller diameter than the outside of this axle. In order to get this off, we're going to have to jack it off. In order to do that, we've got a socket here, and I'm going to apply some load there, push there, and that should force that off. Might try that with a fast clamp first and then see if it does actually work. If not, it's a job for the vice. So this is the axle removed. I've sort of laid this out in sequence. We've got this, which is the seal sort of come preload system. It's a bit worn, this one. Just the inside's just a bit worn. But for the modified one, it doesn't actually matter. This seal goes on here, which doubles up. The bearing that has been used has got an LH seal. It's quite unusual, an LH seal. Most NTN, and it's an NTN bearing. NTN bearings usually come in LU, which is a double contact seal, and LB, which is a non-contact, and LH is a single contact rubber seal. So it's quite difficult. It's actually very difficult to obtain as well. But going back to the axle, we've got shoulder there, bearing landing here with an undercut there, circlip groove here, chamfer, well, it tapers down, and then the hardened section here where the bearing goes. The modified axle looks very similar, but instead of having a hex in the end, it's now got flats here. The shoulder that this sits on is slightly deeper, and that's because the preload system and the bearing that's going to be used is subtly different. I've left the circlip landing in there, and then obviously we've got the hardened section there. The main difference is around the preload system, but I'll assemble this and then I'll show you how we get on. So this pedal bearing is probably the most heavily loaded bearing on a bike. Pedal bearings are pretty small, given that they're probably going to carry your weight. The replacement bearing, it's got a brown seal on it. It is an NSK 6901, and that has a slightly different interference fit onto here. I did ring up NSK just to be doubly sure, and they gave me the fit. So we're going to push that onto there as soon as we put this back. Now, because of the way this axle is set up, we don't need this seal anymore. This will more than take up for it because it's a double contact seal. So we can put this on and then push that back down, and then we should be able to put the circlip back on. The preload system is set by this gap here. So that distance between that shoulder and there gives you the preload. So to get this together, we're going to use that, which is part of the old assembly. Put a little bit of grease on here. Bearing here. Slide that over, and that is a 13mm extended socket. Pop that there and then push it all the way down. Still got a little bit left to go. God, I'll do it with one hand, and nigh on impossible. So we're all pushed up. You can see the socket at that end and the pedal at this end. Now we can reassemble this inside the pedal. So this is all assembled now. So we've got the bearing on there, that's spinning nice and free. Okay, it's a bit draggy because it's a double seal. And then the spacers there from where it was. And we've removed this piece. It's no longer required because there's seals on the bearing. And we're going to put the circlip back on now. It's usually a lot easier to get them back on rather than take them off. So that circlip probably isn't required, but I've just put it on there just to be safe. That's all secure. Now what we're going to do is put this back into the pedal body, get a bit of mobile. Okay, so now we need to put the circlip back in. Make sure it's fully in. And that's it. So now that's fully assembled. That is the left pedal. Now, this business about float and preload is quite important. So this is the original pedal, and if I show you the float on it, it's probably easier if you can hear it. So there's a fair amount of float in there. The replacement, there's hardly any in that one. You can't hear it. So what I've done here is I have put the pedal into the vise and then put a DTI on the top of it. I've set this to be at the very top, so this needle will move up and down. You can see it's gone to minus 0.04 and then back up to 0.05. So there's about 100 microns or 1/10 of a millimetre of float in there. So this one is the replacement, or the extended one, and we've got a lot less float in there. It's hardly anything really, 0.01, 0.02, so that's about a thou if you are in the States. It's that time of the show again. It is time for PowerPoint. Today I have called this PowerPoint SRAM's Christmases All Come at Once. I've missed the apostrophe on SRAMs. But before we carry on, we need to check that pen is working because it's important today. Pen is working! It's been working brilliantly. Right. All of these things you can hit me up on Patreon for more technical stuff. Hambini Eng on Instagram, and I've got some Buy Hambini Aged 5 stickers and merch and all that other stuff. You know, come and buy some so you can support the channel. Right, disclaimer. First of all, I'm 5. Don't believe anything in this presentation because it's probably wrong, and I recommend these independent sources for sound engineering judgment. So Neil Webb from Bowman Cycles, they're now bankrupt. And David Arthur, in his channel, Just Ride Bikes, he plugs Defective Aluminium Bikes, and he's Neil's friend. And also Weight Wankers. Right. Right, Time pedals versus Time bikes. So the original company, you know, in days gone by, Time pedals and Time frames were the same, and they were owned by this entity called Rossignol, and they are French. That entity sold Time bikes to Cardinal Cycling Group. So Time frames are made in Slovakia. I don't think they've even got any French factory anymore. And I've got a Time frame. I've got a Skylon, which I'm trying to build up at the moment, and due to time constraints, I've kind of screwed that up. But anyway, Time pedals, which this presentation is about, is now owned by SRAM. So Time is well and truly shafted by SRAM. So if we go to the SRAM website, this is Time's website,
But up here you can see all the brands that SRAM owns. So SRAM, RockShox, True, Vative, Zip, Quark, Time, Hammerhead, and a few others. This is the Time ATAC. I think it's the modern equivalent. They've called it the Speciale 8 or Special Wheat and Special 12. Anyway, it talks about all these other things. The key thing to note here is this hasn't really changed that much in I don't know how long. I don't even know if they're still made in France, actually. They may be made there, they may be made somewhere else, but anyway. Right, we digress. Let's go back to the PowerPoint. Right, so this is the problem for the customer. So he has got toe out. So his feet, the toes point outwards, and that's giving him a problem with the heels touching effectively the crank spider on the drive side or the crank arm on the non-drive side. There are a few quick fixes to this, and this is what he has tried. So he's tried the easiest fix, which is just to move the pedal outward slightly by using the washer behind the pedal. You've only got so much you can do with that because you reduce your thread engagement as you put more washers in. The other option is these pedal extenders. So they'll give you, the pedal shims will give you like 2mm if you put a washer behind it. These pedal extenders will probably be 14 getting on for 20. And there was a story not that long ago where the safety body in the States, I don't know if they made Specialized recall all their pedal extenders, but they had to anyway. So yeah, you can do that. The engineered fix. Now the engineered fix is to extend the axle. Now the best technical solution for this customer, because he wanted 7 to 8mm, is that, because the threading thing might land you in hospital, and the Q factor is too much. It's not the cheapest option by any means, but if you want custom equipment, then that's where it goes. I'll be honest, this one was technically quite challenging compared to the bottom brackets. I've done a few pedal axles. This one was a bit of a challenge, right? The reason it is technically challenging is because you've got the design element. You're re-engineering something that is someone else has made, so you haven't really gone through the thought process of it, and the practicalities of making it, because it's quite small and fiddly. So that Time ATAC system is still in use today. So I've just shown you the pedals that are there, and fundamentally it hasn't changed that much. The pedal retention system hasn't changed much, and the way the axle setup hasn't changed that much either. The material quality, I don't know if it's better or not, but it's, you still get them in moulded plastic, aluminium. This is a picture of the original on the left hand side and the extended one, which is the one on the right. Yeah, there's not really much else I can say about that. Now, this is a well-engineered product, but Time are not perfect. So when I got the pedal, you can see on the one side, you can see this perfect round hole. And what it is these things are riveted down, and a punch tool comes down and then flattens it. And on this side, the guy that's come to flatten it has missed. So it's damaged the pedal body, and I think it's been like that from day dot. So if you were to get that new, probably reject it, but it's God knows how old. So there you go. Right, the mechanics of this. Now, I've done this from right to left because when you are making it, you usually machine from the smaller diameter to the bigger diameter. So if I go from right to left, there's a needle roller bearing that sits on this surface here. It actually only sits there, but they've made the axle bigger for whatever reason, wanting to hold it or just because they can. It's got a lead-in chamfer there just to make it easier for you to get in. There's a circlip here, which is probably unnecessary, but it's an axial position device as well. Normally you'd use it to hold the bearing in, but there's an interference fit on the bearing, so there you go. 6000 series bearing fits on that surface there. The preload spacer and the seal, so they're combined on the original, sit on this landing here. You've got the threads, which are here, and there's a undercut there, and then the female hex recess there. Right, it is carbon steel, and it's probably forged. I mean, this is all hardened, so the bearing landings are hardened, and they've phosphate coated the rest of it. NTN bearings are standard. This is not something where someone has really skimped on. The only comment that I would make where they've skimped is this preload spacer, because I've seen on the more expensive time pedals they have a collar to screw in the preload system. Now, because I'm retrofitting, I can machine a little bit off to fix a preload, but not everyone's going to do that. In fact, most people aren't going to do that. So that's where the real cost saving is. As far as the rest of the engineering goes in there, this is extremely well designed. So someone who has quite a lot of experience has made, I mean, it looks like a fairly simple product, looks just like a pedal axle, but the features, the way it's been, subtle things like the way you'd hold it, the way you would screw it in if it's seized, those things, someone really has gone to town and looked at it. And the fact they've used an NTN bearing. Now, in the good old days in France, the bearing part of Renault was SNR. That was spun off and it became NTN SNR, but Look used to use NTN SNR bearings in their pedals, and Time, around the same age, did the same thing. These days, the modern Look pedal is crap. Now, I had a pair of Look Delta pedals from, I don't know, when I was 2, and they lasted really well. The modern Look Keo pedals, garbage. Anyway, so this is very, very well engineered. What I've done here is I've shown you the mechanics of what's going on. So when you load the pedal up, you've got this force here, which is held by that needle roller bearing. So when you apply your foot down, it's taking that load. You've got a small amount of that load that transfers into the radial bearing, or the deep groove ball bearing. And because it's fixed on this side, and that's what these arrows represent, the fixation point, you try and turn that, you try and bend that shaft that way. By doing that, that causes this axial component, so that deep groove ball bearing has to resist that load. Now when you make the axle bigger or longer, this moment, which I'll call MX, gets significantly bigger. So if you're looking at, let's say, an 80 mil shaft, and then you've lost 10 mil of it already because of the threads, you've got the remaining 70 mil, and you're extending it by 8 mil, you've got 10% extra torque, which is not insignificant. Right, in order to do this, so some of the engineering behind it, I did some finite element analysis. And now it is, I hate sometimes this, it is the tool of choice for huge add-ons. So for people who come from university, graduates, they love this stuff because they always go on to ANSYS, and they can run rings around it. The crux of it is, I've noticed that the graduates sort of in the UK and off the continent, they are a lot more analytical and they don't have those practical skills. It's almost like a lost, dying art. It is a lot more accurate than CFD. CFD has a large number of unknowns, for finite element analysis, it's a lot more accurate. It's extremely cheap, it's very quick, and I mean, it requires some interpretation with a bit of experience, but it is only as good as the boundary conditions. So the criteria that you put on, so the amount of loads and all that kind of stuff, is only as good as that. So what I've done here is I have got the modified axle, oh god, right, here, the modified axle with CFD plotted, not CFD, sorry, FEA plotted. Now you can see this. Now I've actually used SolidWorks for this. Now I wouldn't recommend you use SolidWorks, and the loads that I've applied aren't real loads. I've only used this for illustration, mainly because, as you all well know, lots of people have started copying my stuff, which is a bit of an irritation. Anyway, this is the axle in the bent state. Now if we go to animate, you can, if we slow that down a bit, you can see how this axle is bending. Now it's not going to bend anywhere near as much as that, but you can see the kind of point where you get the movement. So the stress raises are around those circlip grooves, the undercut, and not so much at the other end. So the needle roller bearing, there isn't actually any stress there, because what have you got? It's only where it fixates itself to the crank arm where the problem is. Now if I go back, I mean, we can take a section through here, but we don't need to. I mean, what I'm looking for is any areas where it exceeds the yield stress of the material. So that's your first thing. You also need to put in a safety factor there. Now, from most industrial things use a safe life. So after 20,000 kilometers or 30,000 kilometers, they'll say that part is worn and you need to replace it. That used to be the case in aero until probably the 1970s and 1980s. Lockheed started doing fail safe. So you build some redundancy in so that if the item should fail, you've got sufficient redundancy around it to take up the load. For this is so over-engineered that you don't need to apply that. And it became obvious when I did the stress analysis how well engineered it is. You would have to have some serious weight, forget the power, to get near trashing it. It would be very, very difficult to trash it. Now, that's one element. The other element is how much bending you get. Now, you don't want excessive bending, and that's another thing that obviously you check for when you are designing. So, this is the extended axle. If I talk you from right to left again, so we've got the bearing landing, same dimensions as OE, and I've made this axle out of stainless. The disadvantage with making it out of stainless versus carbon steel that's been hardened is stainless is actually softer. The issue there is, one of cost. So hardening something where you've only got two axles to harden is prohibitively expensive. I have obviously done the checks on it to see if it's going to gall and all that kind of good stuff, and it will be fine. The taper is slightly shallower because I could make it. I have a sneaky suspicion that the original axle was probably used in multiple different pedals, but there we go. The DIN circlip groove remains the same. It hasn't changed since the 1980s when the standard was developed. The seal is located inside the bearing, so I've removed the seal that was originally in here. The bearing is an NSK. It's a P5 fit on that landing. Notice the small P because it's a male shaft fit and not a female M7 housing fit. Right, and then the preload system is by shaft position. So the preload was a right bit of a faff to do on here, is you have to just take a little bit off, check, a little bit off, check, all that kind of stuff. when I say it's a faff, if I was doing it like I made bottom brackets, I'd do it in like seconds. But the problem is I don't do that often, so it was a bit more time consuming. I've put the drive onto flat, so to screw it on and screw it off, if you ever get it stuck, which regularly happens, getting it off when you've got flat to drive off is much easier than a hex. And I also increased the number of threads just in case he needed a little bit more with some, with an additional washer to give him another millimetre or so. Right, questions and comments. Please put your questions, comments in the box below. I'll read them all. Remember to smash that like and subscribe button. It is a bonus. It also helps the channel quite significantly, especially as I am moving towards increasing the content levels. If you got any more, if you have any more video suggestions, use that box below, because a lot of the stuff now, some of the suggestions, I am reading in there and then tailoring the content to what people want. That brings us to the end of this video. If you did enjoy it, remember to smash that like button. If you didn't, go screw yourself. And as always, keep banging your hairdresser.